Okay, hi Julia. We are on Friday's lesson. We're going to finish going through the answers to the worksheet when we get back on Monday. Partially because Ms. Black borrowed my computer. Excuse me. You get a really good realistic taste of the class, by the way, Julia. Telling people shush. Okay, second, we are introducing something called a hyperbola. If you know the formula for an ellipse, you almost know the formula for hyperbola. This plus turns into minus. That's it. Now keep in mind, since subtraction changes the answer if you could write it backwards, you could write, ellipses backwards, it doesn't make any difference. But if you write a hyperbola backwards, it'll get a different answer, and you'll have a different graph. Now, let's catch up. Oh, right. This, a horizontal hyperbola, look up here. There's another one. Here's the other one. This is called the vertical hyperbola. If you think of it, a hyperbola is just an ellipse turned inside out. You can turn an ellipse inside out two ways. Remember, ellipse, when you have a plus, you're taking this half plus this out and joining them together. If it's minus, you're taking these and turning them inside out. You're going to have a branch going outward this way. It looks like two parabolas. They're actually not. They look a little different than parabolas when I graph them properly. There's another way to turn it inside out. Instead of left-right, turn inside out, you can also turn it inside out, up-down. Did you see that? How do you tell the difference? Well, one of these two equations gives you a horizontal hyperbola, and the other equation gives you a vertical. And I want to take a guess which is which. You have 50% chance of being right. What do you think? Yeah.
Does the first one give you a vertical and the second one give you a horizontal?
Good guess.
Yeah.
Sorry. You were the courageous one who actually took a shot at it, so full points for that.
I thought since you switched the signs on the horizontal, it flips upside down.
Oh, I see. Watch this. This, how do you tell which is which? It's actually a game you learned before kindergarten. Follow the leader. Physically speaking, look at the equality. Your mileage.
Yes, I'm totally kidding.
Your mileage may vary. So, look up here. Which letter, if you read this off just like verbally, what's the very first letter you read? X. This is the leader. It's physically the leader because they wrote it first. This is a horizontal because you follow the X. X goes left, right. Same thing over here. If the Y is written first, Y is the leader. And you follow the leader, which means this is a vertical hyperbola. Does that make sense? So at least we have a fighting chance of knowing. There are two different types of hyperbolas. You can turn it inside out, left, right. Then you can turn it inside out, up, down. How do you tell which one happened? Follow the leader. Whichever letter comes first is the one you follow. Okay. Does anybody have on their notes from days or weeks ago how many analysis points a hyperbola has? 10. 14. Correct. There are 14 elements that you need for a hyperbola. That may sound daunting. The good news is that most of them are retreads from an ellipse. The vast majority of them are. There are, I think, 6 extra ones. And then a couple of them that swap out. For a hyperbola, write these down, please. hyperbola analysis. Keep in mind, like I'll just take this horizontal one. Can we tell me how many vertices it has? Just visual, just staring at the picture. This ellipse is not part of the graph, by the way. That was just to give us an idea. I'll put a phantom there. How many vertices?
Oh, 4. No. 2. Oh, yeah,
Just
no,
2.
I'm sorry.
Does that make sense? There were only 2. I mean, the ellipse had 4. We lost 2 of them. So you don't need the upper and lower one because they never get used in the graph. Or if you have this one, you'll have 2, just the up and down one, because the left and right one's going to get used. Does that make sense? So you only have 2 vertices. You will still have a center. You will still have a horizontal radius and vertical radius. And I'm just going to kind of abbreviate here. Vertical and then ditto ditto. Right, so that's so far? You will still have A and B, but here comes our first surprise. We're used to A being the major radius and B being the minor radius. That is no longer the case. Because with an ellipse, it made a really big difference which one was bigger and which one was smaller. In this one, it doesn't make as much difference. What makes the difference is which way you're opening. Are you opening left-right? Or are you opening up-down? That's the really spectacular thing you notice when you see a graph of this. A is, please write this down, the leader radius. Follow the leader. In other words, if you're looking at this top equation, then the horizontal radius is A, because it's the leader. I don't care if it's big or small. You can have small, think Napoleon, he was relatively short, but he was an extremely powerful leader. So you don't have to be, Goliath in order to be a leader. Make sense? So you can have a leader in a hyperbola even if it's a smaller number. Right? And then B is the non-leader. Can we call it the follower?
That's what I wrote down.
Yeah, that's fine. And the non-leader, you can call it the follower. The non-leader radius. Make sense? Now, there is a focal move. First of all, somebody said that A and B would still be relatively easy to find. You don't pay attention to which one's bigger, you pay attention to which one's the leader. For an hyperbola. C is the focal move. Good news and bad news. The good news is the formula is almost the same. The bad news is there's one teeny change you have to memorize. You want to take a guess? The A squared and the B squared are still there. Yeah. It's plus. It's A squared plus B squared. You might want to notice, how do you tell which sign is in the focal move? Well, you notice in the main formula it's minus. It's the opposite sign of whatever is in the main formula. If the main formula has a minus, your focal move is plus. If the main formula is a plus, like an ellipse, your formula is going to be minus. Okay? Otherwise, you calculate it exactly the same way. There are 2 vertices, B1 and B2. There are 2 foci, focus 1, focus 2. There are a few other things, though. And I think I barely have enough time to cover these. Does everybody have these, the hyperbola equations? Okay. It's high time we actually draw one. It's easier to understand if you actually graph it. I would like you to graph the following. I'll give you instruction as we go. We're going to do more of these. X minus 1 parentheses squared over 16. minus y minus 2 parentheses squared over 9 equals 1. That's what shape? Good. Hyperbola. How do you know? There's a minus sign. Correct. How do you know it's not a circle? 2 reasons. One you already said.
There's a minus sign.
Yeah, there's a minus sign. No circle has a minus sign in the middle.
And they divided by 16 and 9.
Right. A circle is never divided by 2 different numbers. It's always the exact same number. So it's not a circle. Why isn't it an ellipse? Jeff?
Because it's subtraction.
Because, exactly.
Addition.
It's subtraction, not addition. Somebody give me the center.
1, 2.
Good. 1, 2. Horizontal radius. Polly.
4.
4. Good save. Radical 16 is 4. What's the vertical radius?
2, 3.
It's 3. Radical 9 is 3. Sophie, which one of these is A? In an ellipse, which one would be A? Yeah, in an ellipse, A would be Y in an ellipse. What does A stand for in an ellipse? Major radius. Very good. What do we care about now? No, the major and minor done it. The leader. Who's the leader in this? The horizontal or the vertical? Yes. It turns out that by coincidence, A is still this, not because it's biggest, but because it's the leader. Don't be fooled into thinking 4 is A because it's biggest. That's a coincidence. If 9 had been in front and 16 behind, I would have used the radical 9. This is B, not because it's smaller, but because it's the follower. That's the comes with your brochure. Very good, Christopher? Can somebody give me the focal move? No.
So would be a squared, which is 16.
Okay. Radical
minus b squared.
A squared what?
9 plus.
There's one, yeah, plus B squared. Go ahead and plug those in again.
Plus is the square root of 16 plus 9.
What does that give you?
25 squared, 25.
Yeah, radical 25, which is?
5.
We now have a focal move of 5. Good. I'm going to ask in a minute which way they go. Do they go left, right, or up, down? I'm going to take a guess. Yeah,
Left, right.
they go left, right. Why do you say that?
Because the horizontal radius is the leader.
Exactly. Everything follows the leader. Everything. So you're going to follow foci left, right, not up, down. All right. How much time do we have? So we've got. Let's graph this thing. I don't think I'll have time to do anything more than a quick sketch. I take that back. We don't have time for anything except to wrap up. So Monday we will pick this up where we left off. Yes, sir.
We have homework on Monday. I'm not going to be.
Oh, I see. Will we have homework on Monday? If we do, I'll email it to you.
Okay.
All right, please stand. Silly bell. I'm sorry, don't complain. Blessed bell. This left thing is In the name of the Father, and the Son, and the Holy Spirit. Glory be to the Father, to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and the Son, and of the Holy Spirit. Ready? See y'all soon. See you later, Julia. And I won't leave the play button running for 20 minutes like I did last time.